Since the early days of large language models, all we heard was about prompt engineering. So how to modify the prompts, how to decompose them, how can we write them in a way explicitly so that we get the desired responses. In the past year, the conversation has shifted to what is called context engineering. So every time we call an LLM, we need to pass a context uh, for which contains instructions and data for the LLM to respond to the task. So what is context engineering? How do we maintain, update, and compress the context that is being passed here? So let's dig a little bit more deeper into context engineering and see what's the difference. Also see what's the difference with prompt engineering. Context engineering is essentially curation. Okay, so we need to curate and determine what we are going to pass to the language model. It's not just modifying the prompt, there are many other parts to it. And it happens every time we're going to invoke the LLM. So what are we going to curate? Uh, there are two main paths, the system description that we provide to the LLM and the runtime. These are two things that are uh, separate entities. The runtime evolves as the LLM implements the task. So these two things need to be curated at a high level. So the system description consists of instructions that we provide. Not all instructions, not the whole system prompt might be relevant. So what is the subset of the system prompt that is relevant to uh, the instruction, to executing the task right now at this instant? Similarly, tool sets, there could be huge diverse set of tool sets, but only few relevant to the current task. And curation is about figuring out what is the relevant. For example, the skills, anthropic skills are a form of curation that happens around tool sets. Uh, a serious uh, amount of curation must go into extracting what is relevant from the knowledge base. This is what is popularly known as RAG, retrieval augmented generation, where you first curate a relevant portion of the knowledge base that is relevant to the query and the context, conversation context right now, and bring it into the context, and then let the LLM decide what the response should be or what the answer should be. So, this is a significant part of the curation that happens, and there are many optimized ways of doing it. Finally, examples. If you provide a bunch of examples which are related or unrelated to the current context, curation must extract the most relevant examples and then provide them as hints to the LLM to uh, to find the response, to compute the response. So that's the system description part of it. The runtime, as the conversation evolves, build up a conversation history, and that consists of both the user statements and the response, as well as the tool calls and the responses. And as the conversation history becomes longer, a lot of it is not relevant to the current state of the conversation. So that has to be removed. That has to be curated away. So you have to pick a, relevant part of the conversation history. So these two combined together. Uh, so curation has several dimensions, as you can see. All of these must be curated at every step to uh, to allow the LLM to give a appropriate, correct response, accurate response. Um, the earlier, the way we used to build the agents earlier, uh, we used to mainly focus on knowledge-based curation, doing retrieval, doing efficient retrieval to get the context, and then letting the LLM do the response generation and figuring out uh, the relation among the knowledge-based contents. But with, for example, MCP growth or MCP technology, you can provide hundreds of tools and they occupy valuable space in the context. The context is precious. It's finite and precious, so uh, it must be populated very carefully. Otherwise, the LLMs can easily go astray and get confused by the noise. Um, Similarly, instruction skills bring in only a relevant set of instruction. There are many ways to prune the conversation history. So, uh, compaction is in general, the compaction operator in general takes care of the conversation history and extracts the most relevant part of it. The idea is to get the recall first, meaning that you should, after pruning, none of the essential information should be lost. Okay, so recall first compaction, and once you have everything that is relevant, then you can try to remove away the superfluous stuff that is not immediately relevant. Another technique that's used for better context engineering is making notes. So notes are sort of compressed version of the working memory or the conversation history. Uh, there are a number of observed facts or extracted snippets from knowledge base that may not be immediately relevant, but they could be have a global or a long-term effect. So capturing that long-term aspect of the working memory is done by having a um, separate memory component called nodes. Some also call it the scratch pad. Okay, so, so this is the overview of different aspects of context engineering. This diagram from Anthropic is very very nicely illustrates that. This is the whole unpruned context. Several documents, several tool descriptions, instructions, domain knowledge, and message history that's going on, and the curation only finds the small subset, relevant subset of that, and then presents it to LLM, which creates a response. Again, it might result in tool calls, and that incrementally updates the full context. Finally, how does prompt engineering fit in? So the system prompt here is what is often optimized by prompt engineering, although other prompts could also be during the conversation, but this is the key focus. So what happens is that uh, if you don't get the desired results in a particular iteration, then you go back and have, for example, the LLM overlook some piece of the instruction or the data. Then you go back and modify the system prompt so that this gives us the desired information. And this is where uh, a lot of this is where the focus of prompt engineering and a lot of iterations take place until a lot of iteration may be needed until you get the right system prompt. Right, so that's where that's a narrow focus of prompt engineering, where the context engineering takes care of the whole curation that happens over the full context.